As the closest star in the entire universe to us, the sun hides way more secrets than we ever imagined. Today, we're unlocking the hardcore truths behind this absolute superstar of our solar system. Let's jump straight into the biggest question everyone asks. What exactly is the sun? A lot of people would instantly say just a giant ball of fire. But if you ask an astronomer, the real answer is far more mind-blowing. The sun is a yellow dwarf star, and it's not solid, not liquid, and definitely not a burning gas ball like we picture on Earth. It's something way more extreme. A massive ball of plasma, the fourth state of matter. Picture this. Take an ice cube, heat it until it becomes water. Keep heating until it turns into steam. Now keep cranking the temperature to tens of thousands or even hundreds of thousands of degrees. The gas molecules get smashed apart. Electrons get ripped away from their nuclei, and everything turns into a wild soup of positively charged nuclei and negatively charged electrons flying around freely. That chaotic, electrified state is plasma. And the sun? It's a giant plasma sphere 1.392 million kilometers across. Big enough to swallow 1.3 million Earths whole. What's even cooler is that this plasma ball is spinning like crazy, but not the way Earth spins. Earth is solid, so it rotates as one piece. The sun's plasma is fluid, so its equator spins faster, about 25 days for one full rotation, while the poles take around 35 days. That difference in speed twists and tangles the sun's magnetic fields, creating those stunning sunspots, powerful solar flares, and the beautiful looping prominences we see during total eclipses. These differential rotations are the engine behind almost all the dramatic activity we observe on the sun's surface. And they also generate the sun's incredibly complex magnetic field that influences everything from space weather to auroras on Earth. So how did our sun become this giant plasma star in the first place? The story starts 4.6 billion years ago in a giant molecular cloud of gas and dust drifting through the Milky Way. Mostly hydrogen and helium. Then a nearby supernova exploded. Its shockwaves slammed into the cloud like an invisible giant hand, squeezing it tighter and tighter. Gravity took over. Matter rushed toward the center. Pressure skyrocketed, and temperatures soared. When the core hit about 10 million degrees Celsius and the pressure became insane, hydrogen atoms were slammed together so hard they fused. Nuclear fusion ignited. The outward radiation pressure perfectly balanced the inward pull of gravity, and a stable star was born. That's how our sun switched on as a plasma-powered furnace and began its roughly 10 billion year journey of shining. If the gravity won, the sun would collapse into a black hole or a neutron star. If the radiation pressure won, it would blow itself apart in a spectacular explosion. The perfect, delicate balance between these two forces is what keeps our sun stable and glowing for billions of years. It's one of the most elegant examples of cosmic equilibrium in the entire universe. Now, here's the part that always blows people's minds. Why does the sun shine? It's not burning like a campfire or a match. It's powered by nuclear fusion in its core. The core is 15 million degrees Celsius with pressure 250 billion times stronger than Earth's atmosphere. Under those extreme conditions, for hydrogen nuclei smash together and fuse into one helium nucleus, about 0.7% of the mass simply disappears. But it doesn't vanish. Thanks to Einstein's famous equation, E equals mc, that tiny bit of missing mass turns into an enormous burst of energy in the form of light and heat. That energy streams out as photons and neutrinos. And that's what eventually becomes the sunlight warming your face right now. Every single second, the sun converts 4 million tons of matter into pure energy. But the sun is so massive, roughly 2 octillion tons, that losing 4 million tons a second is like losing a single grain of sand from an entire beach. It can keep doing this comfortably for billions of years. That fusion is the reason the sun is the energy mother of the entire solar system, powering every living thing on Earth from the tiniest bacteria to the tallest trees and us humans. Here's a super cool fact most people have never heard. The sunlight you feel today actually started its journey between 100,000 and 170,000 years ago, deep inside the sun's core. You'd think light traveling at 300,000 kilometers per second would zip from the core to the surface in just a couple of seconds, right? Wrong. Wrong. The sun's interior is an incredibly dense plasma soup. A photon gets born in the core, then immediately slams into particles. Hits, absorbed, re-emitted, and scattered in completely random directions. Trillions upon trillions of collisions. Scientists calculate it takes, on average, 100,000 to 170,000 years for a photon to random walk its way to the surface through this chaotic maze. Only once it finally breaks free into open space does it take just 8 minutes and 20 seconds to reach Earth. So the warm sunlight hitting your skin right now was actually created when woolly mammoths still roamed the planet, and our human ancestors were struggling to survive the last ice age. Every ray of sunshine carries an ancient cosmic story that began long before recorded human history. Think about that. The next time you step outside on a sunny day, you're literally feeling light that's older than human civilization itself. And yes, the sun actually has an atmosphere, and the outer part is much hotter than the visible surface. In December 2024, NASA's Parker Solar Probe, the fastest human-made object ever built, reaching speeds of 692,000 kilometers per hour, gave us our first clear, close-up look at the sun's true atmosphere, called the corona. We used to think the bright visible surface, the photosphere at about 500 degrees Celsius, was the end of the sun. Turns out there is no sharp surface at all. Above the photosphere lies the chromosphere and then the corona, where temperatures suddenly jump to between 1 and 2 million degrees Celsius. Parker showed us the corona is not a smooth, gentle flow of gas. It's a violent, dynamic environment full of waves, loops, and plasma being torn apart and yanked back by powerful magnetic fields. Solar wind isn't simply blown outward like wind on Earth. It's constantly being pushed and pulled in a chaotic dance by the sun's tangled magnetic fields. Why the outer atmosphere is dramatically hotter than the surface below is still one of the biggest unsolved mysteries in astronomy. The famous Cornell heating problem. Some scientists think magnetic waves or nanofloors might be responsible, but we still don't have a definitive answer. It remains one of the most exciting puzzles in solar physics today. The sun also sneezes, and when it does, the sneezes are powerful enough to rival billions of hydrogen bombs. Solar flares and coronal mass ejections blast out huge clouds of high-energy particles and radiation. If one of those massive sneezes hits Earth head-on, it can knock out satellites, overload power grids, disrupt GPS, and trigger spectacular auroras, even in tropical regions. In 2012, we narrowly missed one of the strongest solar storms ever recorded. If it had struck us directly, modern electronics worldwide could have been severely damaged or even wiped out, potentially causing trillions of dollars in damage and plunging parts of the world into darkness for months. Scientists now estimate the sun has about 5 billion years left in its stable, middle-aged phase. After that, the hydrogen fuel in the core will run out. The core will collapse, the outer layers will swell dramatically, and the sun will transform into a red giant. It will likely swallow Mercury, Venus, and possibly even Earth. But don't worry, minus 5 billion years is an unimaginably long time. Human civilization will have evolved, spread across the stars, or changed in ways we cannot even begin to imagine today. Some futurists believe we might have colonized other star systems long before that happens. So next time you step outside and feel the sun's warmth on your skin, remember this: you're not just looking at a bright bowl in the sky. You're looking at a 4.6 billion-year-old plasma star that has been fusing hydrogen since before dinosaurs existed. The light warming you right now began its incredible journey when our ancestors were still living in caves. Every single photon carries an ancient cosmic story across 150 million kilometers of empty space just to reach you. The universe is full of wonders, but sometimes the biggest ones are hiding in plain sight right above our heads. One single star, our sun, is enough to remind us how incredible, mysterious, and beautiful the cosmos really is. It's not just our daytime companion. It's a living, breathing nuclear furnace that has shaped every aspect of life on Earth for billions of years.